All right, we're on formative 2, where you're reading and annotating the text, forces that influence the movement of air in Earth's troposphere. You're going to highlight details that describe matter and energy and examples of how they interact with each other. And then you're going to stop and jot to summarize main ideas, make connections, and ask questions after each paragraph. Those are the questions. That's just answering those questions here that I've guided you with. Right. So the main source of heat for air in the troposphere is Earth's surface. Let's highlight that. This is because nitrogen and oxygen air molecules, which make up 99% of our atmosphere, are not at all effective in absorbing radiation directly from the sun, while land and water on Earth's surface can absorb radiation from the sun very effectively. So the question is, why is Earth's surface the main source of heat for air in the troposphere? Because matter in the form of liquid, like water, and solids, like land, are more effective at absorbing radiation, heat, than gas molecules that are our atmosphere. The air we breathe is made of gas molecules. Okay, so I modeled what the first one should look like, but now I'm not going to answer all of the questions for you. I'm going to expect you to do that, but I will keep reading. Okay, sunlight travels through the troposphere mostly unabsorbed and reaches the surface of the Earth. This means that this sunlight warms the Earth, but it also means that the sun is not directly heating the troposphere. Rather, this solar energy warms the Earth, and the Earth emits its own energy to the air molecules when they come in direct contact with the Earth's surface. This type of heat transfer that takes place through direct contact between two objects, like the Earth's surface and air molecules, is called conduction. So how does conduction work on the Earth's surface and atmosphere? Earth's surface absorbs heat from solar radiation, and when gas molecules from the atmosphere come into contact with it, what happens? And you can go ahead and finish that by pausing this read aloud and pressing play when you're ready to go on. Without conduction, transferring and storing heat within Earth's atmosphere, life as we know it could not exist. Remember that heat is considered energy. I'm going to highlight that. And the Earth's surface and the molecules of gas. Heat is considered energy. And the Earth's surface and the molecules of gas in Earth's atmosphere are considered to be matter. Okay, let's highlight that. When energy is absorbed by matter in the atmosphere, air molecules of nitrogen and oxygen begin increasing in movement. Right, so when they get hotter, they start moving around more. Matter that exists in the gaseous phase, gas molecules, right, have these unique properties. They're easy to compress, they're easy to press together, right? They expand to fill containers or spaces like you see here, and they occupy far more space than liquids or solids from which they form, right? So that's why, like, when you heat up a pot of water, the liquid boils and it releases a whole lot of steam, right? And that steam spreads really fast. Right? So here, make sure you take note what is important to know about the properties of gas molecules in our atmosphere. what do you know about the way they move, what happens when they start to get heated up, and the space that they occupy. Okay, so you can go ahead and pause and then play when you're ready to go on. Increasing heat and motion causes these molecules to spread out and expand. So that means they're becoming less dense as they are heated and spread apart. You see this when liquid water that's heated creates steam and spreads and fills your bathroom when taking a shower, or in your kitchen when someone's preparing food for dinner. The opposite is true when you remove heat, or when there's less heat being absorbed by the material. Molecules will slow down in movement and in some situations move closer towards each other, like when liquid water becomes ice. And again, if you need a little bit more info to clarify, I would suggest clicking here for this video, and it'll bring you to a YouTube video that shows you
As a matter of fact, for what it's worth.
All right. So you can go ahead and pause and then press play when you're ready to move on. Don't forget to answer that summary question. All right. How are molecules in our atmosphere held in place? Gravity is very important to us. We could not live on Earth without it. The sun's gravity keeps the Earth in orbit around it, keeping us at a comfortable distance to enjoy its sun's light and warmth. It holds down our atmosphere and the air we need to breathe. Right, so let's highlight that. Gravity isn't the same everywhere on Earth, and this is explained by Newton's law of universal gravitation, explained as so. Since gravitational force is directly proportional to the mass of both interacting objects, like we see here, right? Here's two interacting objects. These have less mass, these have more mass. More massive objects will attract to each other with greater gravitational force. That means that these two objects are larger, therefore they have greater gravitational force pulling each other together. Right? You don't see that here because even though these two objects are the same distance apart than these two, they're smaller, therefore they have less gravity pulling them towards each other. So let's continue. So as the mass of either object increases, the force of gravitational attraction between them also increases, right? That's where we see this happening here. These arrows are representing the gravitational pull between them, or the gravitational attraction between them. And we see since they're larger, or they have more mass, they're increasing that gravitational pull. If the mass of one of the objects is doubled, then the force of gravity between them would also be doubled. And if the mass of one of the objects is tripled, the force of gravity between them would be tripled. Let's delete this. More separation between the two objects, meaning more distance between them, will result in weaker gravitational forces. Right? We saw that when we were learning about eccentricity of Earth's orbit. When it's farther from the sun, the gravitational pull is much weaker. So, as two objects are separated from each other, the force of gravitational attraction between them also decreases. So you see these two smaller mass balls down here are much farther apart, so their gravitational attraction is a lot lower, a lot less than these two, which are closer together. And then you can go ahead and read on your own this description about how NASA used two spacecraft to measure these variations in Earth's gravity. Okay, so I'm going to guide you through this last part where you review your understanding of gravity's effect on the Earth's atmosphere. You're basically going to explain what you learned about gravity and how it works between different molecules of different sizes, right? Just like these balls here. So, review the diagram, which shows the relationship between distance and mass of two objects and their gravitational attraction. Explain how this relationship works. So if I were you, I would start by saying something like, if two objects are farther apart, their gravitational attraction will be. However, if they are closer together, the gravitational pull will be. In addition, the more mass an object has, the greater, the more mass two objects have, then their gravitational attraction will be higher or lower, right? Okay, so I'll let you type that. Go ahead and pause and then play when you're ready to move on to this last question. Based on what you've learned about pressure and gravity, explain why there's more air pressure close to Earth's surface, remember pressure, density, closer together, than there is at higher altitudes in the atmosphere. So you're going to have to go back to the PowerPoint from this week where Mr. Marco explains the relationship between pressure and let's see where it is. I would rewatch this video. And I would also go back to that video with the lady in the parachute from the last formative to help you answer this.